Welcome to the video for 9.1, the idea of equilibria. You need to look at your textbook, and it's pages 146 to 147. The lesson objectives for this lesson are to know that many chemical reactions are reversible, and to understand that for a reaction in equilibrium, although the concentrations of reactants and products remain constant, both the forward and reverse reactions are still proceeding at equal rates. So at GCSE you've already met reversible reactions, and you should know that most reactions are not reversible. So for example, you've got A plus B, which are reactants. They will react together to give C plus D. And that once you've made the product, so once you've made C and D, they remain unchanged. So most reactions are non-reversible. However, there are some which are reversible. And in this case, once the products are made, they then react backwards to form the reactants. So before we had A plus B reacting to give C plus D, once C plus D had formed in a reversible reaction, they would then react together to reform A plus B. And we use this funny reversible arrow here to show that's the case. So you've got an arrow going forwards and an arrow going backwards at the same time. So A plus B, and then a reversible arrow goes to C plus D. And that shows you that the forward reaction from A plus B to give C plus D is going on at the same time as C plus D is reacting to give A plus B. And various points about this are important. So first thing is that when we add the reactants to reactors, they start to form the products. So if you put the reactants in, they will start to form the products. And at the start of the reaction, the forward reaction is going to be faster because the concentration of the reactants is going to be higher than the products. So at the very first point where you just have reactants there and there's no product, of course there's no reverse reaction because you haven't got any product. So it's only once the products start to form that the backwards reaction starts to happen. As the forward reaction progresses, the concentration of the reactants is going to decrease because they've been used up to make the products. And that means the rate of the forward reaction is going to decrease. However, at the same time, because the concentration of the products is increasing because more of them are being made, then the rate of the backward reaction is going to increase because you've got more concentration of products. And eventually you'll get to a situation where we describe as equilibrium. And at equilibrium, the rate of the forward reaction is going to be the same as the rate of the backward reaction. And once that's happened, then the rate stays constant. So the rate of the forward reaction is going to be the same as the rate of the backward reaction. And we call this situation dynamic equilibrium. So as I've said, the rate of the forward reaction is going to be the same as the rate of the backward reaction. And this means the concentration of the reactants is going to remain constant, and the concentration of the products will remain constant. And notice I've not described them as being the same, and that's because sometimes students get into muddle and they say the concentration of the reactants and products is the same. And this can be misinterpreted because this means that the concentration of the reactants is the same as the products, and it's not. It's just that the concentration of the reactants doesn't change and the concentration of the products doesn't change. So it doesn't necessarily mean that the concentration of the reactants is going to be the same as the product. Now we call this a dynamic situation, so it's dynamic equilibrium, because although the concentration of the reactants doesn't change and the concentration of the products doesn't change, it's dynamic, which means moving, because the forward reaction is happening at the same time as the backward reaction. So although the concentrations are remaining constant, the forward reaction is still happening and the backward reaction is still happening. Now sometimes people have difficulty thinking about what's actually happening in an equilibrium reaction, in a reversible reaction. So I'm going to show you a quick model to help you understand this. So if we can think of having two troughs of water. So we have two troughs. So at the start, my left-hand one represents my reactant and the right-hand one represents my product. So at the start you've got lots of reactants there and you haven't got any products. Now if you then had a smaller beaker to transfer the reactants into the products, then as you go from the left-hand trough to the right-hand trough, they become the products. And you can see in this middle situation that some of the reactants have been made into products. So in the first case, the reactants are going to be moved into products, but there's no products that can be made into reactants. So the forward reaction can happen, but the backwards reaction can't. Then once you've got a few products made, you can then start transferring the products back to make reactants. And this will happen until you get an equilibrium. Eventually you get to a point where the reactants will be made into the products at the same rate as the products are made into reactants. So the amount of reactants you've got will stay the same, and the amount of products you've got will stay the same. However, people often don't realise that because it's a reversible reaction, as well as coming it from the starting with just the reactants, you can also start with just the products. So if you had the same reactor vessel that you put the products in to start with, you would have loads of products and not many reactants. So you'd have the backward reaction only going until you get to a point in the middle situation where you've got some reactants, and now you've got some reactants, the reactants can now be made into products. And again, you'll get to the same equilibrium situation, whether you put the reactants in or whether you put the products in. So looking back at our lesson objectives, they were to know that many chemical reactions are reversible, to understand that for reaction in equilibrium, although the concentrations of reactants and products remain constant, both the forward and reverse reactions are still proceeding at equal rates. So as usual, if you don't understand these lesson objectives, then either go back and rewatch the video or have a look at the textbook or do something to make sure that when you come to lesson, you understand these lesson objectives.